Okay, good evening everyone. My apologies for the tardy start, but it was actually semi-intentional. About about an hour before broadcast time I came out, and there was a few wispy clouds out in the sky, but nothing much else to speak of, so I thought maybe we just have a few clouds to dance around tonight. But then, about half an hour before the broadcast, a whole bank of unforecast clouds moved in and have just wiped out the sky. And so, but I could see that on the horizon it was clear again, so I have intentionally started late to try and let the sky clear. And so that's what I have done here, is just wait. And boy, all of a sudden this software is doing something crazy, and I don't understand what it's doing. Okay, anyway, so that's why I started late, so my apologies for that, but the sky is now clearing, so I think we will be able to proceed almost as planned, just with a little bit of a delay. So, yeah, let's see. So I need to get this. Okay, so not the test pattern, and then this is here. Okay, and so now all of a sudden this has gone inverted. The display has gone inverted. I have no idea why. Somehow I think I hit a button that I bet you it was this one. It was. When I was trying to adjust the screen, I accidentally hit that button. And it inverted the image on my screen. Okay, let's make sure you're seeing. Yeah, okay, good. You're now seeing the correct stuff. Alright, so now I need to do this, because we are going to do the December 2023 EAA challenge. Alright, let's get this going over here. Alright, and oh shoot, I put those cables away. Okay, I'll be right back. Okay, so here's the challenge that we're going to be doing, and I don't know how much of this screen you guys can see, because I don't have my windows sized right, but it looks like M74 is going to be our first object. But what I have to determine here is where is it? Because a good 50% of the sky is still obscured, so I don't know where M74 is right now, so we're going to have to go take a look. Alright, so it's going to be somewhere that. Let's look for M74. Okay, where are you? Over by Jupiter, so that's all the way on the other side of the world. That's going to be on the south. Yeah, that's going to be on the east side of the sky. How are the clouds looking? They're mostly gone. Mostly, but not entirely. We're going to have to wait on that one. So that's not going to work. Okay, Caldwell 24. 24. Perseus A. Okay, that I can probably actually do, because that's in the northern part of the sky, which is looking, well, near as I can tell, is looking pretty clear right now. So let's give that one a shot. Okay. So let's start imaging on that. Yes, because I haven't started the guider yet. That's right. This late start has completely discombobulated me. Okay, we gotta connect all of these, then we gotta start this, then we've gotta go back here, try and run this again. Alright. Okay. You are now starting to build. I need to get this over here and do that. Get this started. Okay. Alright. Looks like I guessed pretty well on the screen size. Alright. So. Yeah, looks like I guessed pretty well on the screen size. Alright. Perseus A, active galaxy. Well, let's make sure we're in the neighborhood here using the annotation. This does not look like we are even in the right place. Why would that be? Let's try a plate solve only. Try the annotation again. We are in completely the wrong place. Okay, so we've got to stop this and start over again. Back here. That looks like it there. Well, let's see if we're closer this time. Alright. Get our enhancements turned on here. Hopefully this time we are. Ooh, look at that beautiful satellite just bashing right through there. Oh, look at the littering of galaxies in here. Boy. Yeah, this I believe is the galaxy we're looking for, but we gotta zoom in so far just to get a clear shot at it. I'm really surprised it's the only one it's not telling us about is this one, which is the brightest one in the entire screen, and yet it's not saying anything about it, which is really bizarre. Perseus A, there we go. We've got to zoom in that far to be able to see that that's what it is. Come on. Huh. Well, now suddenly the zoom isn't working. What is going on here? Okay. SharpCap is doing something really, really strange. But what's new? Okay. Anyway, these are all galaxies in here, all three of these. Okay, before I stacked that second one, I was supposed to delete the thing out of there, and I didn't. So we need to reset this to get rid of that satellite trail. Okay, that's a bit better. Yeah, so these are all galaxies in here. Well, as the annotation is showing, these are all galaxies. The brightest and most interesting ones are the ones that it's not highlighting. It's highlighting really difficult to see obscure ones, which is the opposite of what it is supposed to be doing, but there you are. These are all galaxies in here. There's just tons and tons of them. And what did he say about Perseus A? Wait a minute. Where am I? Caldwell 24. So remember, the large Perseus cluster of galaxies is a type of safe Earth. How many galaxies can you see? Yeah. So there's tons and tons of them. All these fuzzy ones. These little tiny sharp ones are stars. But this one here is you see 1275. Let's see if we can get some more information on this from Wikipedia. Wikipedia NGC 1275. Perseus A, or Caldwell 24, is a type 1.5 safe Earth galaxy 237 million light years away. Oh, it actually consists of two galaxies. A central galaxy in the Perseus cluster and so-called high-velocity system which lies in front of it. The high-velocity system is moving at 3,000 kilometers per second toward the dominant system and is believed to be merging with the Perseus cluster. So it's actually this here is actually two galaxies colliding, which we're not going to be able to see very well with my camera, but with this view, because I don't have anywhere near the magnification possible with this camera and scope to see that. But I think what's more important here is just this is the Perseus cluster of galaxies, and every one of these that looks a little bit fuzzy is a galaxy. It's not a star, it's actually a galaxy. All these stars, which are sharp-edged, look much more sharp. Those are all way in the foreground, stars that are in our Milky Way galaxy. And the colors on this are way off. I should not be There we go. That's going to look a whole lot better. So sorry about that. I forgot to balance the colors out. But you know, all these fuzzy spots here. All these are little elliptical galaxies here. Maybe some spirals in there. But 237 million light years away. So all these fuzzy things are way in the background. Basically, if we got to the edge of the Milky Way, all these stars would disappear and you just see these fuzzy dots of light all around. Because they're hundreds of millions of light years away, as opposed to these stars, which are hundreds or thousands of light years away. Let's see if there's anything else interesting they have to say about this. Oh, they think it has a supermassive black hole. They think of maybe a supermassive black hole indicating a central mass of approximately 800 million solar masses, which includes the black hole itself plus its accretion disk and all the matter it's sucking in. I don't know how they tell that stuff, but whatever. Anyway, lots and lots of little galaxies in here. In fact, we can just zoom in a little bit. I can't zoom in. Yeah, see all these fuzzy. Look at all these little fuzzy patches in here. You know, that's fuzzy. This one's sharp. That's a star. This one's fuzzy. It's a galaxy. There's a fuzzy one up there. All these fuzzy ones in here. This one's a tiny little, maybe a spiral. There's a tiny little spiral there. Bigger spiral. All these fuzzy spots. Look at all these things. I wonder how many of them can be identified. Yeah, see this. It can identify that one and that one. These are probably fainter than my catalog. My catalog only goes down to mag 18. So there's 16, there's 17. These are probably over mag 18, so they're not in my catalog. But yeah, there's just oodles and oodles of them in here. Oodles and oodles of them. Let's turn the background music on. Now, I actually listened to the broadcast, the last one I did, and it seemed like the audio was a little low. So I'm going to try turning the audio up some. And see if the audio isn't a little bit better. Looks like the internet is going up and down again. So you guys are probably seeing some hourglassing. Lots and lots of little galaxies in here. There's more of them up here. More fuzzy spots. Another little disk. Looks like maybe a tiny little disk there. Definitely a couple of fuzzy spots up here. One there. I mean, they're just all over the place. That's a fuzzy spot in there, though it's hard to tell what's star and what's not. Probably a galaxy in the background of a little cluster of stars there. Quite a lot of them. And if they're all neighbors, they're all a couple 100 million light years away. Just a ton of them in here. Just a ton of them. Okay. So we did Caldwell 24. Let's see. I think M74 might be out pretty well now. So let's try doing M74 again. Nice little spiral galaxy. And we're currently there, so we're going to be up a little higher and over. Okay. Alright, let's move on to M74. Go. Oop, and there's our galaxy right down there. So it's probably, when I plate solve, it's probably going to zip it right up here into the middle. Doink, right there. Okay. Very good. Start imaging. Alright. Now what does he have to say about M74? Oh, he's getting it from Wikipedia too, but M74, the Phantom, is a large spiral 32 million light years away, so this one's a lot closer than the last one. 200 million light years closer. Galaxy contains two clearly defined spiral arms and is therefore used as an archetypal example of a grand design spiral galaxy. The galaxy's low surface brightness makes it the most difficult Messier object for amateur astronomers to observe. So this is a tough one for visual observers. But we cheat and use a camera, so we should be able to see it pretty well. Look at that. There it is. Yeah, a little bit grainy at first from the first sub-exposure, but it will get better. Alright. Yeah, we'll give this a little bit of time. So about 30 million light years away, huh? Let's see. It's estimated that it hosts about 100 billion stars, which means it's smaller than the Milky Way. We're looking at it almost completely face on, so it makes it kind of nice. Three supernovae are known to have taken place. one in 2013 was so bright that you could with a telescope you could see the star even better than you could see the galaxy. Or at least that's what I read, what they say. Maybe that's not what it says, but it seems to be what they're saying to me. The brightest member of the M74 group. I guess that makes sense. Group of 5 to 7 galaxies also includes the peculiar spiral galaxy NGC 660 and some irregular galaxies. I don't think any of them are in this view. Look at M74. I don't know if that's it or not. A lot of tiny little galaxies in here. What did it say? NGC 660? Galaxy group. Yeah, NGC 660. I don't see it in here. We look in the annotation results. NGC. Boy, I don't see any NGCs in here. Wow. Come on. UGC. But yeah, there's nothing in here. There's no NGC. HR, yeah, would be right there if it was. Huh, interesting. Okay, well, I don't see it. So I'm not sure where the other galaxies in this group are, but this was a pretty spectacular one. Hardest Messier object, I guess the dimmest. Oh, and we have another satellite coming in to photobomb us. Another satellite. Stretch this so you can see a little bit. Yeah, it's a nice slow moving satellite. It's going to take several frames to go through. Well, at least it's not going to go right through the galaxy. It is a pretty one, though. It's still a little bit grainy. We might take a few extra minutes on this to try and let it smooth out a little bit. that was a truly bizarre bank of clouds. But it is now completely gone, and it's just a beautiful clear night. So, that was just bizarre. It was just messing with me. Just a bizarre band of clouds. Obscured everything. I couldn't even polar align because the whole northern sky was blocked out. And so I couldn't polar align on the North Star. On the celestial pole, I should say. Which is just 3/4 of a degree off the North Star, but yeah, I couldn't actually even polar align. I was just kind of stuck. I was set up and ready to go. So that was interesting. Looks like my internet is definitely up and down. Oh well. Let's see how our stretch is doing here. Stretched pretty well. We'll stretch it a little harder. You can see. So you at home can see all much of the wispiness as you can. Also get a lot of the screen stuff out of the way. I have to kind of watch broadcast to see. I have to see how it's going. The broadcast really darkens the image from what I'm seeing on my control computer, where I'm actually capturing the image. What I see here is a lot brighter than what you see on the broadcast. So I have to make it look pretty crappy and blown out on my screen to make it look good on yours. So I always have a second computer going to monitor the broadcast as I'm doing it, so that I can tell how much to adjust it so it looks good for you guys, because when it looks good for you guys, it does not look good for me. But I think that's a pretty good image right there. Like I said, we're going to do a few extra minutes on this because it's such a faint, wispy object that a little extra time will collect some more photons to make it look a little better. This looks like a conch shell. Alright, we'll finish up this sub-exposure and find out what's next. While we're waiting for that, what is next? So the first two, NGC 383. NGC 383. Radio galaxy. Okay, so not too far up there. Alright, NGC 383 group. Alright. There is our M74. In fact, I might even just M74. Might even just keep a capture of that. Let's back this off a little bit so it looks a little bit better on my end. And then we'll save that. Alright, and now we will move on to NGC 383. Okay. Alright. Quick plate solve. Oh yeah, some fuzzy things in there. It's like some more small little fuzzy galaxies. Alright, what did he say about NGC 383? There's a double radio galaxy with a quasar-like appearance located in the constellation Pisces. Recent discoveries by the National Radio Astronomy Observatory reveal that 383 is being bisected by high-energy relativistic jets traveling at relatively high fractions of the speed of light. The relativistic electrons in the jets are detected as synchrotron radiation in X-ray and radio wavelengths. Focus of this intense energy is the galactic center. NGC 383. So, a bunch of fuzzy galaxies in there. See if the annotation gets them. It's off by a little, so let's, after the plate solve, let's do another one. No, everything should be on. There we go, that's better. NGC, that's like a star. I wonder what that is. Yeah, it's a star, so there's a galaxy, another star. I wonder why this star is so special. Bunches more galaxies. These two, I assume, also are galaxies. They must be. Yep. Yeah, Look at them all. Now they're all popping out. When you zoom in close, they all pop out. Okay. Yeah, so these are all galaxies in here. Another image with slews of them. Oh, we are a little black clipped here. Come on, you. Back off just a little bit. Bunches of little fuzzy blobs that are galaxies. And you see 7217. Well, this is building 7217. 7217. Is this also close by? No, this is on the other side. This is in the northwestern sky, okay. That will involve a meridian flip. There's a nice galaxy there. That's like a nice little spiral galaxy probably there. Which one that is? NGC 0374. Mag 14. All these fuzzy dots. There's a nice fuzzy one there too. It's probably fainter than my catalog goes. M1 is in this neighborhood where I am now. The Crab Nebula. Ooh. Actually, I'm going to need more time on that. That hasn't risen far enough yet. Well, actually, I can probably get that. My northeastern sky, if I have pretty low. Well, yeah, that's almost eastern sky, so no, it's too low yet. What have I got here? Yeah, Capella. Ping. Yeah, line from Capella through there. Yeah, it's just a little bit too low yet, so we'll have to hold off on that one. M1, 7217. Open cluster, 103. Do an open cluster next. Okay, let's look at an open cluster. Next target. Alright, so M103. M103. Yeah, it's up here, Cassiopeia. So it's up pretty high. Okay. Oh yeah, look at that nice little cluster in there. I'll just boink, bring that down here. Alright. Start imaging that because this is a star cluster. We're going to reduce the time a whole bunch. Star clusters do not need a lot of time. Color in this cluster. Got some red, some blue. That's pretty nice. Background sky is not real dark tonight because we're here on the west coast. We're under some pretty good onshore flow, so the humidity's up, Pacific moisture streaming on in. But it still turned out to be a pretty clear night tonight after that initial cloud bank at 6 o'clock passed through. Some nice, mainly very faint stars figure in Cassiopeia was discovered in 1781 by Charles Messier's friend and collaborator Pierre Machin. It is located between 8,000 to 9,500 light years from our solar system and ranging over about 1,500 light years wide, or 15 light years wide. It holds about 40 certain member stars, 2 of which have a magnitude 10.5, and a 10.8 red giant, which is the brightest within the cluster. So I guess that's what that is right there, is a red giant. Red giant. Which is what our sun is going to turn into in about 4 billion years. A bright, known foreground object is the star Struve 131, not a member of the cluster. I think that's probably what this is. Let's see if the cluster Gulliver 16. Gulliver 16. The cluster may have 172 stars, if including those down to 50% probability of a gravitational tie. And 103 is about 22 million years old. We've got a nice little mini cluster up there. Look at this, a red star, blue star. Some nice color. Nice color tonight. Nice little trail of stars going off here. A nice little cluster here of faint stars. Kemble's Cascade. K-E-M-B-L-E. Kemble's Cascade. Kemble's Cascade. You see 15 inch, the Jolly Roger cluster. Oh, okay, we'll do that next. It's just below where we are. The Jolly Roger cluster. Nice looking stars here. Huh, it's the only thing they have indicated here. What happens if I zoom in? Just trying to see if it would identify which one is the Struve 131. I think it's probably this one. But I don't know. Don't know. Well, after an inauspicious beginning, it has turned into a beautiful night. A night that they forecast as being a beautiful night. Looks like it's actually going to do that after all. There's some beautiful stars in this. Stretch it a little more. See how it comes out on you guys' end. That is a pretty little cluster. At least 1, 2, 3 red stars in it. Rest all look pretty blue. That one's a yellow. Kind of a pale blue. Some reds and yellow stars out there, right there, right there, there. Pretty sweet. Okay, let's see what the next thing is. The Jolly Roger cluster. Longer slew than I thought. Not sinking. Alright, let's again a cluster, so we'll chop the time down. Jolly Roger cluster. Campbell's Cascade. It is an apparent straight line of more than 20 colorful 5th to 10th magnitude stars, or it is approximately 3 degrees. Oh. Yeah, it's over approximately 3 degrees. Yeah, which means, yeah, there's a streamer of stars. Where are those going? Yeah, it comes off kind of this way, and there's a streamer of stars that are 3 times the size of my field of view. So that's why it's called a cascade. There's a whole string of bright stars all in a line that are way, way bigger than my field of view can do. So yeah, unfortunately not much I can do about that. Well, I suppose I could try. What happened if I did that one? Yeah, my field of view is too small to really be able to see it, so we'll take a few subs of this main cluster, which actually is kind of a pretty little cluster. There's the Pleiades, which I did last time. M45 is the Pleiades, and which is always a nice one to do. And it's a little bit too big for mine, but it works out pretty nice. Over here, Electra Nebula. Electra Nebula. I haven't heard it called that before. Well, let's try and make it the center about there. That should work. All right, nice little cluster. Not as interesting as the last one, but let's go and do M45. I did this last week, but I did this on Friday night, but yeah, it's such a beautiful one that why not? Why not? Why not? This one will let go for the full 15 seconds or 60 seconds, because even though it is a star cluster, it's got a lot of pretty nebulosity around it. So while that's waiting, so we've done all the open clusters. Planetarium, 1535, and GC 1535. Biggest problem with planetaries from my setup is that they're really, really, really small. And that one is still really low. Yeah, it's just above Orion. So that one's going to be a while. In fact, probably won't even be able to, that probably won't be high enough for us to look at tonight till for probably at least a couple of hours. So that one's probably not going to happen for us tonight. Okay, let's get you all prettied up here. Cluster of stars, relatively young stars. Well, I don't know, they're a couple 100 million years old, but they burn hot, so they have a short lifespan. But they're blue, beautiful stars that are just passing through an area of gas and dust, and so they are illuminating it. We're seeing their light reflected off the dust and the gas that they're going through. Definitely a pretty sight. So 1535, we determined we can't do that yet. That's a later in the winter thing for me. Emission, 1491. Now, emission nebulae are great with filters. Perseus. Fossil footprint. Oh, that's a very small nebula. It doesn't look that small. Alright. We'll see what we can get with that. Usually, unlike a nebula that we're looking at right now, a reflection nebula, which is emitting, which is reflecting starlight, which is full spectrum. So it doesn't take you don't really need a filter to see it. In fact, filters kind of negatively impact it. But for hydrogen emission, excuse me, hydrogen emission nebula, those usually stand up much better with filtration because they're much dimmer. And so what helps is to use a filter to knock down all of the stars in the star field and the background sky color, and which makes the emission nebula pop out. So we'll give that a shot and see what happens. But it's almost always better with filters. Stretch the heck out of this. There's a lot of nebulosity in there. Blows the stars out a little bit, but you can see a lot more of the gas and dust. In fact, while that's doing that, I'm going to go switch into a warmer shoe. It's coming along pretty well. What are we doing next? Oh yeah, 1491. Alright, NGC 1491, the Fossil Footprint Nebula. This one could be, I think I'm going to save this. I'm going to save this one, just for posterity. Back off on that a little bit. let's go to the fossil footprint. Let's see how much of this we can get. It looks like this up right up here. Yeah, bring it right down. Twing. There it is there. Okay. Let's see how much of this we can pull in. GC 1491. Mission type Bright Nebula, 9,800 light years away from Earth. Nebula gets its deep red coloration due to many massive stars embedded within it, producing large amounts of ultraviolet radiation and ionizing the hydrogen gas that makes up the nebula. Okay. It is. The star field is not too bad. So the black's clipped a bit though. And we'll have to see. We'll see how much of this we can pull in. It's going to take a little bit of time. Filled with a bunch of red. Is it red giants? Massive stars embedded. Yeah, so it's not. It's just that the radiation from the stars themselves aren't red. The radiation from the stars is fluorescing, ionizing the hydrogen gas, turning it red. See if Wikipedia has anything more on it. Okay, not much. Not much else to it. Distance, yeah, we already knew that. About 10,000 light years away. But according to Wikipedia, it's 9,800 light years plus or minus 2,000. That's a pretty wild approximation there. Let's see if we were using a filter. all the background sky would be knocked down a lot darker, and the stars would be smaller and darker, and so it would cause the rest of the nebulosity to pop out. It would make the nebula look brighter, when in reality all it's doing is darkening everything else, but leaving the nebula alone. But we're not using narrowband filters tonight, so we've got a nice little nebula in there. It's a little small, but you can see you can see it goes all the way out into here and all the way out into here. There's quite a bit of red area in there, but it will take a little time to pull out all that stuff. You can see we're slowly bringing in a little bit more, and a little bit more over time. Probably will continue to if we were to sit on it for long enough, which we're not going to do, but I guess there's the footprint, huh? Yeah, there's definitely more color coming in here, some dark, dusty parts that are obscuring some of it. I'm just starting to see some of it, but it will take quite a while to bring more of this in. What this really probably needs is longer exposure. Filter and a lot longer exposure. I don't normally do something like this for a YouTube broadcast. I usually stick to 60 seconds, but let's see what a 3-minute exposure will do. Means waiting a bit more time, but a 3-minute exposure will probably bring out a lot more. Does not do. So what are we at? 7217. We haven't done M1. We haven't done 1535 because they're all too low. So I think this is. Where does M1 come up a little bit more? Still too low. And one is still too low. Dagnabbit. Still too low. blew this out more. I think I should have deleted what was already there. I was planning on coming back and doing that. Oh well. Yeah, Crab Nebula is still too low. 1535 was up here, just above Orion, and we're still not. I still can't even see Orion yet, so that's still way too low. 7217, where was that? No picture. What's on the west side? Let's do that next. 7217, that means going back over to the west side, but oh well. See what one looks like. Blowout. Okay. Boink. Boink. Yeah, I don't know that it gets a whole lot more. I think it just makes it fuzzier. So there's definitely more stuff there, but I think it just makes it fuzzier. be able to see much more out of this. There's definitely stuff there, but I think we're just going to head over to 7217. See how much of that we can see. There. We'll let the plate solving pull that up to the center. No, it's not that. That's not it. There's no galaxy there. Let's go back where we were. Yeah, there it is right there. Okay. Start imaging. Okay. 7217 is an unbarred spiral galaxy. So where everything is just kind of a smooth spiral, or an infinite number of smooth spirals, or I don't know. You want to work that. It's a gas-poor system whose main features are the presence of several rings of stars concentric to its nucleus. Plus, there's several rings of stars inside the innermost ring that was discovered previously, which suggests that its central regions have suffered several starbursts. There's also a very large and massive spheroid that extends beyond its disk. Other noteworthy features this galaxy has are the presence of a number of stars rotating in the opposite direction around the galaxy's center to most of them. Alright, we need to readjust this for our correct exposure so we can see it's not a very big guy, that's for sure. Not a very big guy. Pretty small, but definitely there. So we'll see what we can figure about it, but it's basically just a smooth swirly pattern. There's no arms, gravity hasn't put arms together or anything. It's just a smooth swirly spiral galaxy. And it has two distinct stellar populations, one of intermediate age on its innermost regions, and a younger metal-poor version on its outermost ones. It's been suggested these features were caused by a merger with another galaxy, and in fact the computer simulations show that this galaxy could have been a large lenticular galaxy that merged with one or two smaller gas-rich ones, becoming the spiral galaxy we see today. However, right now this galaxy is isolated in space with no nearby major companions. More recent research, however, presents a somewhat different scenario in which the galaxy's massive bulge and halo would have been formed in a merger and the disk formed later and is still growing, either accreting gas from the intergalactic medium or smaller gas-rich galaxies, or most likely from a previously existing reserve. Zoom in as much as I can without making it look too crappy. this is just going to need a little bit of time. Starting to see a little bit of the swirly pattern. If you use a little bit of averted imagination, sort of see some of the swirling there. But because there's no distinct arms in the swirls, they're hard to see without more resolution, more brightness. far away is this thing? About 50 million light years. 50 million. Let's see. Wonder if I can get him one yet. I wonder if I can get it yet. LNAF. Oh, that's Betelgeuse. Yeah, that's the top of Orion. That one is there. I think I can get M1 now. I think it's just barely high enough that we can get that. So we'll do another minute or two on this. Because the more we do on it, the more those arms are likely to be revealed. Well, the non-arms. Just kind of a fuzzy swirl with a core and a fuzzy swirl around it. Sub in, and then maybe we'll go to 15 minutes. Well, 2 more minutes isn't going to make any difference. Almost start seeing it. In any event, let's go try M1. M1 should be a little more interesting than this, even though that's not a bad little object. Okay, and again we're meridian flipping back across to the other side again. That fuzzy blob. Okay. The Crab Nebula is a supernova remnant and a pulsar wind nebula. I didn't know that. In the constellation of Taurus. Let's get this balanced, and that adjusted, and this adjusted back. Those stars look a little streaky to me, so I think we are going to reset this. So I think the mount was still moving a little bit there. The stars are a little streaky and not round. The common name comes from a drawing that somewhat resembled a crab with arms produced by William Parsons in 1842. So his drawing kind of looked like a crab, so that's how it got the name. Even though that's not really what it looks like now. That's a lot better. Now we got regular round stars going on there. M13, what are you doing? Okay. That's got some nice round stars, so that looks better. Okay. Okay, so William Parsons, 3rd Earl of Rosse in 1842 or 43, using a 36-inch telescope. He drew and made a drawing of it that resembled a crab, and that's where it got its name. The nebula was discovered by English astronomer John Bevis in 1731. It corresponds with a bright supernova recorded by Chinese astronomers in 1054 as a guest star. Hold on, I gotta turn on my power there. Okay, they called it a guest star. The nebula was the first astronomical object identified that corresponds with a historically observed supernova explosion. At an apparent magnitude of 8.4, comparable to that of Saturn's moon Titan, it is not visible to the naked eye but can be made out using binoculars under favorable conditions. The nebula lies in the Perseus arm of the Milky Way galaxy at a distance of about 6,500 light years from Earth. It has a diameter of 11 light years, corresponding to an apparent diameter of some 7 arc minutes, and is expanding at a rate of about 1,500 kilometers per second, or 0.5% of the speed of light. At the center of the nebula lies the Crab pulsar, a neutron star 20 to 30 kilometers across, with a spin rate of 30 times per second, which emits pulses of radiation from gamma rays to radio waves. At X-ray and gamma-ray energies above 30 keV, the Crab Nebula is generally the brightest persistent gamma-ray source in the sky, with measured flux extending above 10 TeV. In the 1950s and 1960s, the Sun's corona was mapped from observations of the Crab Nebula's radio waves passing through it. And in 2003, the thickness of the atmosphere of Saturn's moon Titan was measured as it blocked out X-rays from the nebula. The earliest recorded documentation of observation of astronomical object SN 1054 was as it was occurring in 1054 by Chinese astronomers and Japanese observers, hence its numerical identification. Modern understanding that the Crab Nebula was created by a supernova traces back to 1921 when Carl Otto Lampland announced he had seen changes in the nebula's structure. This eventually led to the conclusion that the creation of the Crab Nebula corresponded to the bright SN 1054 supernova recorded by medieval astronomers in AD 1054. In the early 20th century, the analysis of early photographs of the nebula taken several years apart revealed that it was expanding. Tracing the expansion back revealed that the nebula must have become visible on Earth about 900 years before. Historical records revealed that a new star bright enough to be seen in the daytime had been recorded in the same part of the sky by Chinese astronomers on 4 July 1054. Probably also by Japanese observers. It's expanding. Kind of see a little bit more color showing up in it, starting to show up in it. A little more red on there. Push and stretch just a little bit more. In this case, it's actually looking better on your screen than on mine. The colors are more noticeable. The red streamers or strings or crab legs or whatever they are more visible in the... Maybe I can sneak the saturation up a little bit and see what happens. Crank the saturation up a little. Coming along. Now, what haven't we... What do we got? We got 7217. We just got M1. Got M45. So we got all these things. Yeah, so the only one we have not yet done is 1535. That one was still pretty low. Let's look at it. What, yeah, that's the one that's next to Orion. Betelgeuse has just barely risen. You know, I might just be able to get it. I might just be... No, this is a little... Yeah, it's a tiny little guy. Yeah, less than an arc a minute in size, so... maybe. We'll be able to go get it. It's going to be very small. It's not going to be... Basically, it's going to be the size of a large star. So, I'm not sure how well I'll be able to get it, but we'll be able to see a blue circle there, at least. But we'll give the Crab Nebula here a few more minutes. because we're starting to really see some of that red color come in. Very interesting looking nebula. Did they say how far away it was? 6,500 light years. Okay. 6,500 light years. Alright, we'll do one more on crab. One more we'll do this last sub and call it good. And then we'll go over and do the last object. 15 minutes. Back the stretch off just a little. And save as seen. Okay. Oop. Then we're going to go to Cleopatra's Eye Nebula. Okay. Oh yeah, see, it's just a large blue star, essentially. Okay. 1535, Ghost of Neptune. Okay, NGC 1535. Discovered by William Herschel in 1785. It is very similar to the Eskimo Nebula in both color and structure, but the central star can be quite difficult to observe visually. At the center of NGC 1335, there is an O-type star with a spectral type of OH5. Okay. And it's what? Distance 6,000 to 7,000 light years away, it looks like. Okay, balance the color, balance this. It's there. Big blue. Ah, see again, we got streaky stars, so we'll have to reset this. Once again, everything in that picture is supposed to be round, not egg-shaped, including the nebula. So, let's reset this. Get back to everybody being round. That's much better. Stretch it less. Yeah, there we go. We actually get to see it a little bit better when it's stretched a little less. So what you can see here, I don't know if you guys are gonna, I'll have to see what you guys are seeing in the broadcast, but when you stretch it less, you can see that there's actually a fuzzy halo around it, and then there's a blue shell and a sort of a white core where the central star is still burning. Now you're starting to see the pixelation of the camera, but it's actually looking okay for you guys. Just tweak it a little bit. Central star is actually showing up pretty well. There's a bright color. Oh, this is actually a star. There's actually a star in here. It looks like maybe it's behind it. Must be in front of it. It's a star. Well, who knows? I don't know. This will be in our galaxy, so it could be a star that's behind it. But there is actually a star that's right there. But you kind of get the idea of the structure. So this is just the initial gas layers, and this is a shell of a more dense gas, blue dense gas in here, and then there's kind of a gap, and the central star is sort of burning in the middle there. And the planetary nebula are basically the death process of a star. They don't have anything to do with planets. They were misnamed planets. They never have been planets. But when they first saw them, they knew they weren't stars because they were clearly bigger than stars. And Neptune had just basically been recently discovered when they started discovering these planetary nebulae, so they just assumed they were all planets. But obviously they're not. They are actually the death process of a main sequence star, like our own sun. When our sun in about 4 billion years, 4.5 billion years, as our sun starts to get elderly, it will actually start to expand and turn into a red giant. In fact, it will expand so much that its size could actually come out as far as the orbit of the Earth. So it will really be very, very massive in size. And when that happens, the core actually shrinks. So the gas in the outer layers of the sun expand into a red giant, and the core shrinks. And because the core now has lost so much material in the gases that have expanded away from it, it no longer has the gravity to hold on to all that expanding gas. So the gas just keeps expanding outward and outward. And so basically the star just starts shedding a lot of gas from that used to make up the star. But the core itself keeps shrinking, but it doesn't stop burning. It's burning dimmer and less hot, but it's still burning. And so as it's blowing off these layers and layers of gases, the light from the star lights it up and irradiates it. And so it becomes this very big glowing area that is what we call a planetary nebula. So everything we're seeing here was once part of this star and is being blown outward and is slowly dissipating outward into space. And that's what's creating this effect that we're seeing. And so, like I said, in about 4.5 billion years, our sun is going to do probably the same thing. It's not a bad view considering my scope really isn't designed to do tiny things. Didn't come out too badly. See, and as we continue to bring in more data, you can see the dark separation between the blue shell and the central star in the core is starting to separate out. So the longer we go, the more this would kind of darken in here and show that it's actually separate. It's a separate thing. There's a gap between the star, and it's an uneven gap, but there's a gap between the star and the blue shell that's expanding outward. And then the faint outer ring is just the initial gas that was shed from it. Hey Curtis, thanks. I think this is the first time I've ever done this one. So, what's this called? The wife of the Eskimo? What is it called? Eskimo's Wife Nebula, Celestial Jellyfish, or Ghost of Neptune. Yeah, these were it was around the time of the discovery of Neptune that these planetary nebulas started popping up. And so this one's the Ghost of Neptune, being pretty similar to Neptune in color. This star is also starting to tighten up a little bit too. It's not so blobby as it was. It's starting to coalesce into a more sharp shape, not unlike this star here. But that's what, if you look at the Hubble image of this, this is just a star that's in here. Whether it's in front of or behind this nebula, I don't know. I think it's in front of, because in the pictures it looks white. So I think it's probably in front of, in the foreground of that planetary nebula. We'll do another couple of minutes on this. This is our last object of the night, so I will call it quits here at the end of this. Thanks everyone for being here and sticking it out with me to the end. Hope you got to see some interesting stuff. I did tonight. I got to see two or three things that I don't think I've ever imaged before, including this one. So thank you, Say, for a good challenge this month. Got to see a couple old friends and got to see a couple of new things too. So that was pretty cool. cool. Also, just starting to be able to see it's not perfectly circular. It's kind of oblong down here and up here a little bit. So, given more time, I certainly would be able to pick up a bit more detail, but this is really at the resolution's at the limit of my camera. I mean, I'm at 227% zoom, so I'm like way in there. You can certainly see the pixels of my camera, but it still is picking up some of the detail. But anyway, yeah, I'm gonna call it a night. Thank you guys for being here. I appreciate your hitting the subscribe button and the thumbs up and whatever else. And you know, thanks. I'll